This is the whole cooling system for our car. Now, the internal combustion engine is totally insane. To propel a car forwards, we burn fuel inside a cylinder to create heat, and that heat causes gas to increase in pressure and expand, forcing a piston down and pushing a crankshaft around. That's incredibly convoluted. It's also totally genius. Now, when the fuel is burnt, part of the heat that it generates is converted into kinetic energy or movement, about 20%. But the rest of that heat energy stays as, well, heat, and we need to get rid of it. Now, before we even start talking about coolant, there's a reasonable question here. Why bother cooling the engine at all? Why not just let it run hot? Okay, well, firstly, metal expands when it gets hot. And while we've been building this engine, we've been careful to set the clearances between moving parts, pistons and walls, camshafts, crankshafts, and so on. So, if we had perfect clearances between those moving parts when the engine was at a certain temperature, by the time it gets up to 1,000 degrees, those parts have expanded and all our clearances are now in total chaos. Since the clearances are set to allow a certain flow of oil, our lubrication system would now struggle to prevent friction. And what does friction do? It creates heat. So, increased friction would add even more heat into the engine. Plus, at high temperatures, the oil itself would begin to break down or even burn. And very high temperatures would cause parts to warp and generally distort. Eventually, some part would get so hot that it would melt and weld itself to another part. That's a seized engine, otherwise known as a bad day. But even if the engine didn't get so hot that it seized up, it would run terribly. If we don't remove heat from the cylinders, then the temperature in there would be way up in the thousands of degrees, and our fuel mixture would be totally unpredictable at those temperatures. It would pre-ignite before the compression stroke finishes and ruin the careful timing needed for smooth running of the engine. Now, the engine is pretty impressive as it is. It can run anywhere from the Arctic to the desert, but running it on the surface of the sun, that's just a little bit too much. So the engine has to be designed to run within a particular temperature range, and the cooling system is there to remove excess heat and keep the engine within that operating range. It is important to say though that the cooling system shouldn't overcool the engine. We don't want this thing to be ice cold. Heat is needed to keep the fuel vaporized in the cylinders and to stop it from condensing on the cold cylinder walls. What we're aiming for here is for the cylinder head temperature to be about 200 to 250 Celsius, 390 to 480 Fahrenheit, something like that. Now, there are two basic methods of cooling engines, with water and with air. Otto's first four-stroke engine was water-cooled, with a space for water to flow around the cylinders called a water jacket. Now, all modern car engines also have water jackets, and they're filled with a mixture of a water-based coolant. The way the coolant system works is that when the engine is at operating temperature, coolant is pulled out of the bottom of the radiator by the water pump, and it travels along this hose and up here to the water inlet. Then gets pulled into the front of the engine block, and it travels around the cylinders up into the cylinder head where it cools the valves, and it then comes back out of the cylinder head through the thermostat housing along this hose into the radiator to be cooled down. Now, that's what happens when the engine is warm and it needs to be cooled down. But when the engine is cold, we need to get it up to temperature as fast as possible. So in the front here is a thermostat, which is basically a temperature controlled valve. And when the thermostat is closed, it keeps the coolant circulating inside the engine until it's warmed up. Once the coolant is up to temperature, we need to start cooling. So the thermostat opens and the coolant flows all the way around the radiator where it's cooled down by the airflow. The airflow coming from the forwards travel of the vehicle or by a fan when it's not moving. So there's a general flow of coolant up through the engine and then down through the radiator. At the back of the engine, there are two hoses connecting to the heater matrix, which sits behind the dashboard. Here is our dashboard, here is the driver's seat. In here is a small radiator, and that is the source of heat for the blower fans inside the car. Hot water comes out of the back of the cylinder head and it travels past the coolant temperature sensor along this hose into the heater matrix. It then leaves the radiator, or the little radiator that we have inside here, travels down this hose along this metal pipe that runs underneath the exhaust manifold back to the water inlet, where it's pulled back into the engine by the water pump. Now, notice that there's no thermostat on this heater circuit. Water is flowing through the heater all the time the engine's running. Looking back at the front of the engine, we have two more hoses to look at. These come out of the thermostat housing just before the thermostat, and that means that coolant is always flowing along them. In fact, the only hose here that's blocked by the thermostat is this one that leads over to the radiator. Now, one of these little hoses goes over to the throttle body, which is here, and we'll talk about that when we put the air intake on. The other small hose, this one here, is a bypass hose, which ensures that there's a constant movement of coolant around and near to the thermostat. And without that bypass, the thermostat might just be sitting in a patch of static cold water while the rest of the engine gets hot. This whole system is pressurized, and so we have on the other side of the engine an expansion tank here, which allows any expansion of the coolant to be taken up and also acts as a reservoir. We'll talk about that more when we talk about the radiator. Now, the route of coolant inside the engine is determined by the temperature of the engine's internals. This diagram of gas temperatures show where the majority of cooling is needed. The combustion chamber is hottest at 2000 degrees, and as the gases expand down the cylinder, the temperature falls considerably. The intake ports are not much above ambient temperature, but the exhaust ports are hot with 800-degree exhaust gases flowing through them. The surface area of coolant in contact with those hot spots needs to be larger to remove the larger amount of heat. Now, we already talked about the water pump when we installed that onto the engine. In the next few videos, we'll cover the rest of these components. But in the next video, we'll take a quick look at air cooling.